ladies and gentlemen. We are looking at notes 1.5, which are on inverse functions and their properties. Question number 1 is a review question, but it will help us to kind of move into today's topic. So question number 1 says, given the function f of x equals 5x minus 3. So we have a linear function, and it asks us to find f of 8. So remember, to find f of 8, it means that 8 is your input. So you're going to do 5 times 8 minus 3, which is 40 right here, minus 3, so you end up getting 37. So you know that f of 8 is equal to 37. And then if I were to graph out my line, I would know that my line would pass through the coordinate 837, okay? Now part B is a little bit different. Part B says find x such that f of x equals 107. So this time the input is unknown and our output is given to us. So if we have f of x equals 5x minus 3, and we know that f of x right here is equal to 107, I'm going to replace f of x with 107, and then I would just solve it like a regular equation. So I would add 3 to both sides, so I would get 110 equals 5x. Then I would divide both sides by 5, and I end up getting the x's 22. So what does that tell me? It tells me that when my input is 22, my output is going to be 107. Or in other words, in order to get an output of 107, we need to have an input of 22. Actually, what we did right here, the reason why we added 3 here is because we did the inverse of subtraction right here, okay? So that's why we added 3 to get 110. And then here we divided by 5 because we did the inverse of multiplication. So if our function right here tells us to multiply our input by 5 and then subtract 3, to do the inverse, we're going to add 3 and then divide by 5, okay? So the inverse of a function is just the reverse of the original function. And essentially what it does is it undoes what the original function would do. Okay? So question number 2 says to find the inverse of the function defined by f of x equals 2 minus 5x. So we're going to actually do this using 2 different methods. So method 1 is to simply just do the inverse operations. So here this is saying to multiply by negative 5, then it's saying to add 2, because according to order of operations we do our multiplication here first and then we do our addition. So since this is negative 5 times x, we multiply by negative 5. Since this is positive 2, we add 2. So method 1 is going to tell us to do the opposite. And to do the opposite, we also are going to go backwards. So since I added 2 last, here what I'm going to do is I'm going to subtract 2. That's the first thing I'm going to do. Okay? Then it says to, right here, what we did first is we multiplied by negative 5. So what I'm going to do is I'm going to divide by negative 5. Okay, so that means that my function's inverse will be written as follows. Now, this notation right here means the inverse, okay, and that's key for you to know, okay? So we're going to write down that we're going to say that f to the negative 1 of x just means inverse of f of x, okay? So to find the inverse, I'm going to take my input, subtract 2, and then divide my whole answer by negative 5 right here. Okay, so the inverse of f of x here is x minus 2 over negative 5. All right, awesome. So to do method 2 now, essentially what we're doing when we're finding an inverse is we're doing the reverse of the original function. So when you do the reverse, essentially you're just going to switch your inputs with your outputs. So we're going to swap inputs and outputs. Okay? So if you remember, I could use y here instead of f of x. So I'm allowed to say y equals 2 minus 5x. But if I'm going to swap my inputs and my outputs, I'm going to literally switch the positions of my y and my x. So here this would become x equals 2 minus 5y. But I want everything in terms of y, so I'm going to isolate my y here. So to isolate y, I'm going to subtract this 2 right here from both sides. So I get x minus 2 equals negative 5y, right? Then I would divide by negative 5, so that means that y is equal to x minus 2 over negative 5, just like what we got right in this example right here. Say that the inverse of my original function is x minus 2 over negative 5. Or if I want to, I'm allowed to divide the x by negative 5 and divide the negative 2 by negative 5. So I would get negative 1/5 x, and then negative 2 over negative 5 is positive 2/5. So my resulting inverse is still aligned because it's in the format y equals mx plus b. So is the inverse a function? Yes, because it's still aligned. It won't always happen that way, but in this example it does. Okay, all right, so let's revisit part B up here. So right here it says find x such that f of x equals 107. But essentially what this is saying is find the inverse of 107, okay? So in order to figure that out, another option that I have is to use method 2 on this function up here. So if this function says y equals 5x minus 3, when I swap my inputs and my outputs, I get x equals 5y minus 3. I can add 3 to both sides, so I get x plus 3 equals 5y. I can, let me just do this right here. I can divide everything by 5, so I get x plus 3 over 5 equals y. So I'm allowed to say that my inverse function is x plus 3 over 5. So now to find f inverse of 107, I would just plug in 107 in for x here. So I'd do 107 plus 3 over 5, which is 110 over 5, which is equal to my 22. So hopefully you can understand how all these different methods can work to get you the correct answer and the relationship between all the different methods, how they're all saying the same thing. Now the key piece that I want you guys to understand about this is that since you are swapping x and y's with each other, swapping inputs and outputs with each other, so I want you guys to write yourselves a note right here that the inverse just swaps x with y, and because you do that, you end up getting a reflection in the line y equals x. And again, the line y equals x is essentially saying change your x with your y. They're allowed to be interchangeable. And I'll explain to you what I mean by that graphically. All right, so what I'll do is I'm going to graph out my original function in question number 2. So I'm going to write f of x equals 2 minus 5x right in Desmos, and I can see what my line is going to look like. And this should not be a surprise because the y-intercept is 2 and it has a slope of negative 5. It goes down 5 over 1. Okay, awesome. So now let's do our inverse function. So I'm just going to call it g of x is equal to, and then I've got x minus 2 in my numerator all over negative 5. And if you notice, this is the graph that I end up getting right here. Now, essentially what's happening right here is I'm taking all of my, like any coordinate that I have right here. If you notice right here, for example, this coordinate is 0, 2. If I were to swap 0 with 2, over here I would have 2, 0 on my graph. So they're going to be opposites of each other. They're going to switch with each other, okay? Another example right here would be negative 8, 2 right here. So if you look right here, negative 8, 2 on my original function should be at 2, negative 8 on, sorry, negative 8, 2 in my inverse function should be at 2, negative 8 on my original function. So they're going to be swapped with each other. So what do I mean by the fact that it's a reflection in the line y equals x? Well, if you look right here at the line y equals x, I can see that if I were to fold along this green line right here, then what I have here would match up, my red graph would match up with my blue graph if I were to fold along my green line. And I'll show you this a little bit more clearly right now. Notice right here, to get from this point right here, this 0, 2 that I was talking about, to get from there to my line y equals x right here, I would have to go down diagonally 2, and then if I go down another 2 diagonally right here, I end up at 2, 0, which is the reflection in the line y equals x, okay? If I wanted to reflect, let's say this point right here in the line y equals x, I would go diagonally all the way through 1, 2, 3, 4 boxes. So I would go through 1, 2, 3, 4 more boxes this way, and I end up at the inverse function. And if you notice right here, this coordinate right here is going to be 1, negative 3, and then if I look right here, this coordinate is negative 3, 1. So you're essentially just swapping, like we said, your inputs with your outputs, and it ends up being a reflection in the line y equals x. All right, so question 3 says, use the graph of each function to obtain the graph of the inverse. And then it asks me to find out, is the inverse a function? And we're going to explain whether or not it's a function. So right here, remember, all we're going to do is just swap x and y. So if this coordinate right here is negative 3, 1, when I swap it, it ends up becoming 1, negative 3. So I can go to 1, negative 3, and this is one of my points in my inverse. The next point that I have here is negative 2, 1. So then when I swap it, it becomes 1, negative 2. So I'll go to 1, negative 2, and I have a point right here. Okay, I want you to go ahead and try the rest of the coordinates, 1, 2, 3, 4 more coordinates, do the inverse, and then come back to me when you're done so you can check to see if you did it correctly. The remaining coordinates that I should get are 1, negative 1, 0, 1, and negative 2, 4, because I just took each one of my coordinates and I swapped them. So let's go ahead and draw in the line y equals x, just to make sure that this really is the inverse function, and to see if these are really going to be, these coordinates are really coordinates on our inverse. So when I reflect over the line y equals x, do all of these points reflect over it? Do they all match up? Absolutely they do, and I apologize, you guys. There's one point left that I forgot to do. So let's go ahead and do this point. So this point right here is 0, 3. So we'll have a coordinate 3, 0 on our graph, and that still matches up. So we also have 3, 0 on our graph. Now, one thing that I want to talk about is the original graph that we have here is a function because it passes the vertical line test. But the inverse is not a function, and I apologize for that. I just wanted to erase the lines. The inverse is not a function because it doesn't pass the vertical line test. Okay? All right, so now question B, I have a line this time and I want to find the inverse of my line. And essentially, I only really need 2 points in order to define a line. So what I'm going to do is I'll take my my x-intercept and my x-intercept and my y-intercept, and I'm just going to swap those. So I know my y-intercept is going to be 0, 3. So when I swap it, it'll become 3, 0. Okay? And I know my x-intercept is 5, 0. So when I swap that, it'll become 0, 5. So I can go ahead and graph those points out. So I've got 0, 5 right here, and then I've got 3, 0 right here, and then I'm just going to connect my dots, and that's going to be my line, and that's going to be my inverse function. Well, we'll see if it's a function in a minute. Okay, so this right here is going to be the inverse of my original function. Okay, and let's use g inverse of x because this is g of x right here. So now, same thing, let's just go ahead and graph out our line y equals x to see if it really is a reflection right here. And when I look at it right here, if I were to fold along my black line, would the green line match up with the blue line? Absolutely it would. So this is my inverse. Now, is my inverse a function? Does it pass the vertical line test? Well, it's another line. So the inverse is a function because it passes the vertical line test. sorry, let's write this properly. The inverse is a function because it passes the vertical line test. Okay? All right, number 4, find the inverse of f of x equals x squared plus 1. Remember, in order to find inverses, you're just going to swap x and y. Okay, so if my original function says y equals x squared plus 1, this time instead of y, I'm going to use x, and instead of x right here, I'm going to use y. Okay, and then I just solve for y. So in order to solve for y, I need to subtract 1. And then in order to get this y alone, I need to take the square root of both sides. But remember, whenever you take the square root of any number, you get two answers. It could be either plus or positive square root of x minus 1 or negative square root of x minus 1. And hopefully you've noticed by this time that whenever you have a y squared right here, you're always going to have two outputs right here in order to get that y alone. Okay? So can we say that the inverse is a function? No, the inverse is not a function. Because an input, so when I put a number in for x right here, can have more than one output. And I'll show you what that means in 1 second, or I'll just clarify that in a second in case you're not fully understanding that. So first of all, we can say that inverse of f of x is equal to plus or minus the square root of x minus 1. So like for example, if I wanted to find the inverse of 5, my input here is 5, then I would have plus or minus 5 minus 1, or plus or minus root 4. So I get plus or minus 2. So when my input is 5, my output is positive 2 and negative 2. Right, number 5, find the inverse of f of x equals x squared plus 1. But this time we're going to restrict the domain and we're going to say we're only looking at it when x is less than or equal to 0. So it's the exact same function, so my inverse function is still going to be plus or minus the square root of x minus 1. But if my x's and y's are going to swap, this time our domain right here, x is less than or equal to 0, still applies right here. So if x is less than or equal to 0, then positive values won't work. So it's only the negative square root of x minus 1. And next time I see you guys in class, we're going to look at this a little bit more in depth graphically so you can truly understand questions 4 and 5. But I have a question that I would like you to think about before I see you next time in class. And actually, before we move on, we have to answer, is the inverse a function right here? So yes, it is a function because this time I only have one answer as opposed to two answers here. So for example, if I were to find plug 5 in right here, then it would be the negative square root of 5 minus 1, or negative square root of 4, or just negative 2. And no matter what input I plug in, I'll always have one output. So we can say here the inverse is a function because each input has only one output. And that's due to our restricted domain. Okay? Now, one thing I want you guys to just think about for next time I see you guys in class is, you know how we use the vertical line test to determine if something is a function or not? So if I were to draw a vertical line through any of these graphs right here, each vertical line will intersect with each individual graph only once, right? What kind of a test can we use on an original function to determine if the inverse is going to be a function or not? Okay, so what test for original function to determine if the inverse is also a function? Think about that for the next time I see you guys in class, and we'll discuss that in class. Okay? Have a great day.